Good day everyone, welcome back to MSCC online tutorial. In this tutorial video I want to show that gamma half equals to square root of pi. So let's get started. The first thing we need to know here is the gamma function, which is gamma n equals to integral from 0 to infinity e minus x raised to power n minus 1 dx. So this is what we are going to use. So we are going to solve this in 6 steps. So let's start. Step 1, we let x equals to phi squared, so that we need to get dx from here. So dx will be equals to 2 phi d phi, that is differentiating x in respect to what? Phi. Now we substitute. We have gamma n 0 to infinity a minus, now our x is what? Phi squared, then our x, which is phi squared, into, now we're going to put it in this place. You know that 2 will open this bracket, so it will become 2n minus 2 multiplied by dx. Now my dx is 2 phi d phi multiplied by 2 phi d phi. So from here, using the law of indices, this will become 0 to infinity e minus phi squared phi raised to power 2n minus 1. Then this is my 2, let me bring it out here, 2, then I'll be left with the phi. Why do I have minus 1? Because this is phi and this is phi. Phi raised to power 2n minus 2 times phi raised to power 1. Using the law of indices, the one we affect this, the plus 1, so it will become minus 2 plus 1 to give me minus 1. So this is my gamma n. So now when n equals to half, when n equals to 1 over 2, that is gamma 1 over 2, gamma 1 over 2 will be 2 integral 0 to infinity. Now that is, anywhere I see n, I'll put half. This is e minus phi squared phi 2 into bracket 1 over 2, because my n now is half, minus 1, then the phi. If you take a close look at this, you see that these two will cancel this, so I'll be left with 1 minus 1, which will be 0. That is phi raised to power 0, which will give me what? 1. So I have my gamma half to be 2, 0 to infinity e minus phi squared d phi. That is, here I have phi raised to power 0, so it's 1. So now the second step, step 2, we let I to be equal to integral 0 to infinity e minus phi squared d phi, so that I can write that gamma half equals 2i, because my I is this. So let's call this equation asterisk. So let's continue. So now from here we start to solve our I. That is, we say I equals integral 0 to infinity e minus phi squared d phi. So the way it is now, we let the third step. So we let my phi to be lambda psi. So if phi equals to lambda psi, now we are going to differentiate phi in respect to psi, so that the phi will be lambda d psi. That is, I'm differentiating in respect to psi. So if you differentiate psi, you get 1 times lambda, that's lambda, then the psi. So that my I will become 0 to infinity e, you know, this is phi squared, and phi is what? Lambda psi, so it will become minus lambda squared psi squared. Now instead of my d phi is now lambda d psi, so it will be times lambda d psi. So the next thing is to multiply we multiply both sides by e minus lambda squared, and then integrate with respect to lambda over the limit 0 to infinity. Sorry, this is open here. So 0 to what? Infinity. Let's make it an open set. So over this limit 0 to infinity. So now let's put this statement here. So I'm integrating both sides 0 to infinity. Let's say I should multiply by what? E minus lambda squared d lambda, that is integrating in respect to lambda, and this will become double integral 0 to infinity. Now this will be e minus lambda squared psi squared dot e minus lambda squared. This is my lambda. Let me bring it out here. Let me put this here, lambda. So I'm bringing it out, multiplied by the lambda the psi, just as we have it there. Okay, so we continue on a new page. So from here, what we have here now, this is this is psi squared. Now we're going to use the law of indices to bring this together. So let me just leave my left hand side the way it is, so that when I need it I'll bring it there. This is lambda double integral from 0 to infinity. This will be e minus lambda squared 1 plus psi squared. Using the law of indices, I'm bringing out the common factor, which is minus lambda squared. So here I have the lambda the psi. So now I want to integrate this function in respect to lambda. So that will be that will be lambda. This my integral for psi, it will still remain the way it is. Now I will have e minus lambda squared 1 plus psi squared. Then I'll divide by, because this is I'm integrating a function of a function, so I'll divide by differentiating what this my e is carrying. That will be, it will give me minus 2. So let me put the minus here and put the 2 here, 2 lambda, because if I differentiate minus lambda squared I will get minus 2 lambda. So this will be, then I'll have 1 plus psi squared. The reason why it's not affecting this psi is because it's a constant. So it's like when you have 2x squared and you want to differentiate, I'm only going to differentiate x squared, so that it will give you 2x, then the 2 will multiply the 2 to give you 4x. So that's just what I did here. This is a constant. I only differentiate this my lambda and keep the constant. Then I'll put my boundary of integration, which is from 0 to infinity. Then I'll be left with the psi. So now let us check what we have here. So now this lambda will cancel this lambda. So now let us substitute for lambda. That is, my upper bound I'll put infinity, my lower bound I'll put 0. So let's see what we get when we do that. Don't forget this minus here. So this will be integral 0 to infinity. Now if I put infinity here, this will be minus e raised to power minus infinity. Anything raised to power minus infinity is 0. So putting the upper bound, I get 0. Now you know that I'm still left with, let me bring this my 2 outside here. 1 over 2 is here. So the minus, let it be here, this minus. Now open the bracket. When I put the upper bound, I got 0. It is minus, put the lower bound, minus, put the lower bound. Don't forget there's 1 plus psi squared here, so I can put that here because we are not putting anything inside there. Psi squared. So now when I put my lower bound, when I put 0 in place of lambda here, I will get, it will be e minus 0 raised, that is 0 we multiply this, so we have e raised to power 0, and anything raised to power 0 is 1. So here I have 1. Then here I'll have the psi. So we'll continue. I'll get, so this is just, if I open this bracket I will get 1. So this is 1 over 2 integral 0 to infinity d psi over 1 plus psi squared. So now this is what we have. So from here now we just need to integrate, but don't forget that this is a standard integral. When you integrate a function that is like this, that is 1 over 1 plus anything squared d, that same thing, you will always get tan inverse of that thing. So this is special, this is a standard integral. So this will give me 1 over 2, That is, I'm integrating, and this will be tan inverse of what? Psi. Then from what? 0 to infinity. So now again, let us put our lower bound and our upper bound. So when I put my upper bound, the meaning of sine inverse is what angle is the sine infinity. If you punch your calculator, you will see that tan 90 is infinity, is undefined. So tan 90 is undefined. So tan inverse of infinity should give me what? 90, which is what? Pi by 2. And tan inverse of 0, tan inverse of 0 is 0, so this will be minus 0, and this reduces to pi over 4. So now let us come back to our left hand side that we left earlier. So let's come back to the left hand side. So here I will have integral 0 to infinity I dot e minus lambda squared d lambda, which is now equals to what? Pi by 4. Now let us bring out this I. 0 to infinity e minus lambda squared d lambda equals to pi by 4. Now don't forget that, so that we let I to be something earlier. So now let us change this, because lambda is a dummy variable, is constant. So let us change our lambda to phi. So change lambda to phi. You'll see that I'll have I, let's put multiplication here so that will be very clear. I times, because this is I times 0 to infinity e minus phi squared d phi, which will be equals to pi by 4. If you recall that we said let I be what? Let I be integral 0 to infinity e minus phi squared d phi. So this is still the same thing as I. So I have I times I equals to pi by 4. So which implies that I squared is equals to pi by 4. So now if I want to get I, what do? I take the square root of both sides. Then I have I equals to square root of pi over 2. Now let us cross multiply. If we cross multiply, we have 2I equals to square root of pi. Don't forget, in my equation asterisk, the one that we used earlier, we said that gamma half, you can just go back to check. We said gamma half equals to what? 2I, equation asterisk. So since we have that, we can just say therefore gamma half, because this is 2I, and 2I equals to what? Square root of pi. So gamma half equals to what? Square root of pi. And that is the proof. Thank you very much for watching. Don't forget to share with your friend. MSTC cares about your success.